Hi, this is Felipe. Today I'm sitting with Alex Koshaliv from DataRobot, and he's going to be showing us some of the capabilities of the platform. Alex, thank you so much. Take it away.
Thank you, Felipe. So just before I kick off, I promise just one slide, brief intro to the product. So one of the key things I wanted to highlight is that it's essentially a single platform where we wanted to bring a number of different key users across the life cycle of an end-to-end AI project. So you can see there are, from your typical data scientist to bringing in you also business analysts, right? And throughout the demo that I'll be showing, you will see that there's also like a big component of the product is around democratization of data science.
Yes.
You can also see that there, we also want to enable our operators, so like your DevOps, IT, and also consumers of the software. And essentially all of this is underpinned by, the unified end-to-end platform that basically helps you, bring in your data and even just bring in an idea and take it from that inception of idea to the final application that can bring benefits to the business. And so throughout the demo, you'll hear me kind of wearing two hats. So from the actual modeling perspective, we really provide a lot of efficiencies for seasoned data scientists. It's almost like this Iron Man suit where you can really pump out a lot of models as opposed to spending weeks and months on just building one. But at the same time, there's a very easy to use low code, no code interface to democratize AI for less technical users, your business analysts or people with data background, but not necessarily data science background. And again, you will see that throughout. Another problem we really wanted to solve is that, a lot of the models kind of never see the light of the day and end up being on the shelf. So because your IT teams, they speak Java, right? And your data scientists speak Python and R. So DataRobot's MLOps capability really breaches that and allows you to deploy not only DataRobot models, but also your existing external models at a click of a button and then monitor and manage them, most importantly, for drift, for service health and things like that. And then finally, once the model is in production, there's a lot of ways DataRobot can help consume and track the business value associated with it. And all of this is essentially underpinned by a lot of governance and trust that is built into the model. As our chief product officer said before, it's democracy is only as good as the set of rules and controls that govern that democracy. So this is where really we bring that democratization aspect in.
Love it.
And then maybe one last quick note, you can see we basically work with a lot of different types of data. A couple of interesting ones to highlight is we work with images and also geolocational data. Check out, there's a lot of cool videos floating around on the web where we're really showcasing that capability. And then finally, we really wanted to make DataRobot flexible to let customers own AI so you can deploy it pretty much anywhere.
Awesome. That is great. Thank you so much, mate. I didn't know about the images and geolocation, so that's great. And thank you so much.
Awesome. And just a quick intro in terms of the demo that I'll be showing today. So I'll be focusing on automated time series capability. So DataRobot can do a lot more than just time series. We can do, typical regressions, like the family of classification problems and things like this. And now branching out into unsupervised learning as well. So check out our latest release and keep an eye on the upcoming new one. But for today, the key scope is the time series capability. It's a really kind of new hot functionality. A lot of our customers are getting a lot of benefits out of it and really see it as a best in class.
Fantastic. Yeah, it's a hot topic. So keen to have a look. Thanks, mate.
Cool. And basically the place where I'll start is essentially with the data, right? If we were to go and deploy an AI application, the first place is data. So DataRobot basically provides a lot of different plugins and connections into a number of different popular systems. So you can see here, your IT team can pre-configure a number of sources. You can connect, to a lot of the common ones like Snowflake, AWS and things like this. And so once you've plugged in your sources, you can basically pull data in and do some additional manipulation around it. And so this particular tool that I'm showing you right now is essentially our data prep tool. Really makes it easier to do a lot of the typical data manipulations that are currently done in your Python or R. So it makes it easier for less technical users But the other thing is it also really provides like a set of like governance and tools to like make sure that all of the steps that I'm taking are controlled. And I'll quickly show you like one cool functionality that I really like. So for example, in this particular case, we will be predicting store sales for a number of different stores. So I have like about 10 different stores, but there's a bit of an issue here. You can see that the store called Louisville, it actually shows up 3 times, right? So happens all the time, different casing or typos. And DataRobot really allows me to quickly rectify this problem. So it basically uses clustering capability, which helps me identify that, you know, there is a couple of similar values, which I want to replace with my common name to make sure that my model recognizes them as just one store. And so,
right. And sorry, and is this done at the only at the training side, or does it continue to be done once it's been deployed if the source data looks the same?
So that's a very good question. So essentially, I can use it for 2 main purposes. I can either prepare this data for predictions, and if I have an existing DataRobot deployed model, I can actually use this data for predictions, or I can use this data to kick off a modeling project. So both, basically.
Yeah, great. So I'll be fixing the data as it comes in as necessary.
Yep, exactly. And so all of these steps, you can see that basically the steps that I take will be saved, and you can then automatically apply them to your to any new batches of data that you pull in.
Right.
So once I'm happy with my data, basically, I can in this particular case, I'll kick off a modeling project in DataRobot. So now I'm ready to move on to the next step and bring it forward for modeling. So basically what I did here, I pushed this data into DataRobot, and at this stage, DataRobot performs a couple of additional checks and balances here. So if I'm a citizen data scientist, what's the main thing that I need the platform to do for me? Perhaps like help me, guide me through some of the common best practices and steps that I need to take before I start modeling. So you can see DataRobot checks for some quality issues. So you identify outliers in a couple of features, and also checks for things like excess 0 or some of the disguised missing values. There's also some statistical measures that are provided that, you know, your typical data scientist will usually check for and make sure that, you know, there are no issues with the data, that it all looks good before they actually trigger the modeling process. Again, as a citizen data scientist, like I want the process to be simple and intuitive. And this is where really that sort of democratization kicks in through guidance and guardrails in place. So really all I need to do is basically determine what I'm going to be predicting today. So in this case, sales in the store. You can see system automatically identify that it's a regression problem. It also prompts me to consider doing some time-aware modeling. So in this case, it found that there is a date feature, and it actually prompts me to consider some time-aware modeling. There's a couple of different modes here, right? One is, which is the main focus for this demo, is time series forecasting, right? So in this case, I want to look ahead and see what my sale is going to look like in a week's time, right? Or like in 2 weeks, to make sure that I can, you know, bring relevant stuff into the shop, or like maybe downsize if we're not expecting high volume of sales. You can also do your typical automated machine learning and just use time-aware component for out-of-time validation. Or you can also do some nowcasting, right? So maybe like model a couple of scenarios of what certain parameters might look like today based on some of the existing inputs. Very popular for economic analysis, but really the main focus for today is the forecasting.
Yeah, that's great. And I didn't know you guys had the nowcasting in there, so that's a great option too.
Yeah, absolutely, absolutely. Our like customers in financial services really love this one. So basically, you can see once I pick the time series forecasting, the system also prompts me that there might be some series identifiers, right? We want to know, like, are we dealing with one store or several stores? And in this particular case, it's a multi-series problem. So we're dealing with several different stores, as you remember from that data view. And there are 10 different stores here. So once I set it up, the next step for me, essentially, and pretty much the last step as a citizen data scientist, is to make sure that I tell the system how far ahead I want to look. And also, most importantly, also define the window of how far back do I want to look to generate some additional features. And this is a beloved feature for a lot of the like advanced data scientists that we work with. So a lot of their time is spent basically deriving a lot of additional features for time series modeling. And I'll show you in a couple of minutes what the output of this is going to be. It's pretty exciting. So in this particular case, I actually want to model about a week from now. And so I guess the reason for this is, oops, sorry. Early in the morning, I can't type. Basically, the reason for this is sometimes you actually want to leave this kind of operationalized gap. Like you might know the information for tomorrow, but there's not really much you can do about it. If you tell people, don't come to work tomorrow, it's pretty mean to your staff, right? So you might want to leave them a bit of a gap period before you actually do that. And so really, again, as a data scientist, you can see a lot of the guidance and guardrails in place. It's very, very visual. And like some of the practitioners dealing with time series would know that, there's a lot of things you need to balance in your head when you deal with time series. There's a lot of complexity. And that's what DataRobot really tries to break down. So again, as a citizen data scientist, all I need to do at this stage is just hit start and kick off the modeling. But some of the more advanced data scientists might actually want to have more involvement in the process and actually make some other additional decisions. So DataRobot provides flexibility for that as well. So there's also ability to set up a lot of advanced options. You can see DataRobot automatically partition the data to make sure that we are training the model on the past data and actually validating it on the future data. That's how it's going to be working in the production. But you can actually tweak a lot of these things. You can add additional back tests. You can change the validation periods, maybe optimize for a particular period of holidays that you're looking to predict and things like this. There's a whole array of another cool features that we can maybe leave for another session, but things like, you can consider doing segmented modeling or like hierarchical modeling. Sometimes for some stores, you might not have a lot of history, right? Only like partial history and no history at all if you open the store. So DataRobot can handle a lot of that complexity as well. And sometimes you might actually not have you might have sort of gaps in your data. Maybe like a luxurious store have 0 sales on a particular day. DataRobot helps you actually fill up some of those gaps and maybe aggregate, right? Maybe you want to predict on a weekly basis. So time series data prep and DataRobot helps you do that.
Great. Yeah, I was about to ask about that. So that's excellent to know that you can fill gaps and do aggregations and any necessary data prep there. That's great. I think some of the things you might be showing a bit later is around the defining the feature derivation window. I think is that coming later?
Oh no, that's pretty much you can see here essentially, right? So like I basically picked the automated setting to look back 35 days, but you can actually expand this window. And so what DataRobot will do, it will actually look back and look for like other additional periods here. So you might actually look at 7 days, 14 days,
right. And
then based on that, derive a lot of different features. And I'll show you how those features will look like in a minute.
Fantastic. Yeah, great. Yes. Thank
awesome.
you.
So let's say we're happy with everything, with all of our decisions that we've made, and we're ready to hit the start button and basically kick off this automated process of deriving the features. And another thing that DataRobot will do once it sort of derives all those automated features, going 35 days back, what will happen as well is DataRobot will actually pick a subset of models that are most relevant to this particular problem that we're trying to solve, but also like based on some specificities of the data set. And it will run all of them against this data set and pick the best one based on the particular error or validation metric. So this process will take around 30 minutes. So to save us time, sort of in the best practices of cooking shows, I'm gonna like flip forward to the final result.
Love it.
So here you can essentially see that DataRobot evaluated about 38 models and picked the best one. But before I even jump into models, let's actually quickly look at the data. Look at all of those additional features that DataRobot has derived. And so you remember we started with roughly maybe like 15 different columns. And you can see that DataRobot derives 311 new additional features. And you can see some of those bubbled up as like the most important ones. Things like, your 30-day mean, different aggregations. DataRobot performs a lot of like different sort of differencing techniques here as well. And if you want to understand what's going on, you can actually drill into each one of these features, and there's a clear lineage telling us what happened. So in this case, basically just taking a rolling mean of 35 days.
Yeah.
There's also other additional sort of things you can look into to understand what happened under the hood, right? So DataRobot actually considered even more features than those 311. It actually looked at about 600 features and discarded some of them that it didn't find important for predictive purposes. DataRobot also identified a couple of different things like periodicity and actually tested a couple of additional windows like 7 days, 14 days, which you can see in those features. So a lot of efficiency in terms of, like some of our clients that we work with spend weeks sometimes just going through this process of trying, testing, and engineering these features.
Yeah, literally weeks. So this is fantastic. And it's great that it's transparent as well, that you get to see everything that's been tried and how well it worked.
And you can see from a data quality perspective, DataRobot has looked at a couple of additional things as well, that inconsistent data gaps, lagged features and things like this. So once we're, again, happy with all of the features that have been derived, we can actually go to our leaderboard and see what's the best performing model. And you can see DataRobot is like pretty much one step ahead of us. For someone who is like citizen data scientist, I don't need to worry about picking the model, like preparing it for deployment. DataRobot has already done this for me by training it on all of the data. So you can see there are basically NAs here because, we've used 100% of the data. So what we can do to evaluate this model is actually look at the model that's been used to train this final one. And let's actually drill into it. So there's basically all of the steps are clearly documented in the blueprint. You can drill into any of the steps to see like what's actually going on under the hood. Look at DataRobot model docs. And as a citizen data scientist, so as a business user who is interacting with this, what I really want to understand is that, what's sort of like how transparent this model is, right? Like, what are the key predictors of my sales? And this is where the feature impact really comes into play. So you can see that most predictive feature is actually past history of sales, right? And that's the common sort of observation with time series. But we can also see that one of the features, a tourist event, is another thing that drives sales, right? So if there is a particular tourist event happening in the future, we might expect like a spike in sales. But it's not only enough to know that, that this feature is most important. We also want to understand the relationship. So what's that relationship, right? And you can see with feature effects is that basically based on the value of your historical sales, for example, you can clearly tell what will be the spike in your predicted sales. Or like with your tourist event, for example, if there is a tourist event, what's that increase do we see? So it's roughly about 40K in sales driven by this event. So something that is really useful when you need to explain this model to the business, but also make decisions around this. And then finally, all of the predictions that are made, there are clear prediction explanation underlying each one of them. So again, you can take it to the business and say, well, this is why we expect high spike of sales on this particular day. And so at this stage, as a citizen data scientist, I might actually hand it over to an experienced data scientist to do some review for me. So remember that sort of compliance and guardrails in place. So I can assign this project via workflow for approval. And as a data scientist, I might actually say, all right, I want to actually evaluate this model a bit further to make sure I'm happy with everything. And there's a number of different techniques and tools here. You can see there's a plotted accuracy over time. So how well you're predicting against the actual values on any given day in our validation period. You can also see like some insights in terms of the series. So, which shops are actually we're predicting very accurately and which ones are our outliers, which ones we might want to drill in and maybe build a separate model for. And other things like, model stability, how well it performs on different backtests. If you see sort of this being really wobbly, you might want to consider picking another model. So you can see a lot of the things, again, for traditional data scientists, a lot of the things that take a lot of time, additional time to manually derive, engineer, and do it kind of like over and over again for each project. So DataRobot kind of eliminates a lot of that mundane, repetitive tasks and makes it easy for data scientists to really focus on adding value and like creating new exciting models.
Exactly, and also being able to work closely with the stakeholders, because things like the series insights, for example, I love that because it really helps direct the stakeholder attention as to, you know, diving deeper into why there might be some outliers and how is that store different, and trying to find ways to either make it higher performing or increase the predictability. This is great, man. Loving it.
Exactly. And then one last thing that probably will make data scientists excited in terms of the automation is there's also automation around compliance documents. So you can basically automate a lot of this compliance stuff. And especially for some of the more regulated industries, there's a lot of time that goes into creating these documents. So DataRobot brings in a lot of that information that we've seen and automatically puts into the doc. So it really kind of does 80% of the job in terms of this compliance documentation. And again, we know that data scientists really like to tweak things. So they want to like basically apply their best sort of hyperparameter tuning techniques. So there is all advanced tuning capability available. We can go in and like tune any of the models, change some of the hyperparameters, and kind of like experiment with this. DataRobot really makes it quick for data scientists to run a number of different experiments and quickly visualize the results. And while I'm on this topic, I might actually quickly show as well, you know, a lot of the things that I showed you using the UI can be done using APIs, right? And then again, we know a lot of the data scientists, they live in their notebooks and Jupyter notebooks. So all of these things can be automated and done even more efficiently using APIs, running factories of models and things like this. And maybe really quickly, the tool I'm showing here is DataRobot Zeppel Notebook. Just to explain it in one sentence, it's basically your Google Doc or your Office 365 online Word to the Word that installed on your machine. It really kind of brings it into cloud, enables collaboration, enables enterprise governance as well, building libraries of different sort of best working code snippets and things like that.
That's great.
And then finally, when we're happy, the next step is to basically get this model into the production. And DataRobot makes it really flexible as well. So you can deploy it at a click of a button and turn it into like spin it up as an API, as a real time or like a batch API, and then start consuming as part of like any production applications. Users can use DataRobot to consume the predictions. And I'll show that as well in a couple of minutes. And then in that spirit of that flexibility, really helping clients own their AI, they can also extract it as a Docker image or like as a jar code and basically just directly deploy on their environment of choice.
Really? Shit, that's great. Wow.
And I guess that's probably a nice segue into the next capability I wanted to show briefly is our MLOps capability. Oops, let me actually quickly show it here. So essentially, in terms of MLOps, it provides customers with like one single pane of glass where you can monitor all of your different models and not just DataRobot models. It also can be your external model. So here you can see it's a model built in Python or a model built in Java. So it really like in that spirit of flexibility. And it's kind of like in best practices of DevOps, right? But not just looking at your service health, but you can also like be alerted about any drift issues, any accuracy issues and things like this. And if I drill down into a particular, into like a particular deployment that I prepared, so you can see for the sales store forecasting, we might notice that our store capacity feature is starting to drift. So for example, COVID happened and suddenly you see that some of your stores have like 100% capacity, right? They're just empty basically. So you can be quickly notified about this and jump in to rectify that issue. Or also set up the model to be automatically retrained on the most recent data and make sure that your model is up to date. Because basically like once the model is deployed, it's just half of the job done, right? It's usually like, it only is as good as it is for like for a couple of months, and then you need to retrain it. And so DataRobot really alleviates a lot of that manual effort associated with that. And one last quick cool thing to show here as well, you might actually set up not just one model, but run a couple of challengers in parallel to basically act as sort of like a backup plan, right? Maybe one of your models, you can see that, you know, the accuracy is starting to drop, the model is performing a bit worse. So you can actually see how are your other challenges are doing, and you can then quickly swap the model and have like the best one running at this particular point. And that's actually quite cool as well for like any of the legacy models, right? You can test them against the DataRobot's repository of models and pick the best performing one.
That's great. That's excellent. And it would also be enticing for people that like handcrafting their models, so they can put it in the deployment, and you can have it as a backup plan, or it might become the new champion. You can put handcrafted models in the mix. That's great to have multiple challenges here. I love it.
Yeah, exactly. And I promise one last thing to show is basically what's in terms of consuming the model. And oftentimes we see, your business users, like for example, your marketing analyst or like your procurement analyst, they don't necessarily have time to wait for IT to like, spin up an application for them, or even like pull the data into like Tableau. Sometimes that might be a bit like time consuming for them as well. So what DataRobot did, it actually created AI applications capability when you can actually directly visualize the predictions delivered by DataRobot in an AI application. So here you can see basically some of our predictions over time, and business can kind of show it on an iPad in a meeting and start making quick insights. Even like maybe they want to like deploy it somewhere in their existing app, and there's a period of wait. They can fill this gap in and like start actually using and getting actionable insights.
Mate, this is great. This is excellent. So the end-to-end process all in the one platform, from ingesting data preparation, creating multiple models, being able to understand what features have been created, what models have been created, choose to deploy, get the insights to the business users, and have that all governed in the one spot. It's fantastic, mate. Thank you so much for sharing all this today.
Awesome. Yes, thanks a lot. You pretty much done the summary job for me. It's exactly that.
Thanks, mate. Thank you so much. I'll stop the recording here.